This is your presenter Asloob Mudassar, and I am presenting slide number 37 of the course on laser physics. Question is, calculate the stimulated emission transition rate W21 for the case of single atom with a two-level system. Answer. The calculation of stimulated emission transition rate denoted by W21 with superscript as SA for the case of a single atom with a two-level system begins with the following facts, which are the same for absorption transition rate W12. The facts are: number 1, same wave functions for the two-level system. Number 2, same interaction energy and same Hamiltonian. Number 3, same probabilities of existence of atom in level 2 and level 1. That is the same mod square of A21 as a function of time and mod square of A1 as a function of time. Number 4, same magnitude of electric dipole moments, that is mod square of mu21 is equal to mod square of mu12. The first 3 points are obvious and the fourth point can be proved as given. By definition, mu21 is defined as integral of u2 star e r u1 with an integral with respect to dv. And star is actually the complex conjugate of u2, but I shall be calling it as star. Now let's take the complex conjugate of both sides. So we have mu21 star is equal to the integral of, and then we have taken the star of the terms within the integrand, within the integral, that is the conjugate, complex conjugate of the integrand, and then the integration variable dv. And then the integral is equal to, then we have applied the conjugate on all the terms. So we have a mu1 star, er, mu2 and dv, and that is equal to this by definition is equal to mu12. So from this we can say that mu21 star is equal to mu12. But you see that their absolute values will be equal. Thus mu21, thus the absolute square of mu21 is equal to the absolute square of mu12. The initial conditions are however different. The initial conditions are absolute square of A2 at time t is equal to 0 is equal to 1. That is, the atom initially exists in the upper state level. And absolute square of A1 at time t is equal to 0. That is, the level 1 at time t is equal to 0 is empty. The transition rate W21 is thus obtained from equation 36.16 by interchanging the two indices. So from equation number 36.16 we have obtained W21 by interchanging the indices. So W21 is equal to 2 pi square over 3 n epsilon naught ch square into I, where I is the intensity of the illuminating beam, and mu12 mod square of mu12 into g of nu minus nu naught. So you see that here we have changed the indices, and then that is equal to 2 pi square 3 divided by 3 n epsilon naught ch square into I into mod square of mu21 into g of nu minus nu naught is equal to w of 12. Because we have used this fact that is mod square of mu21 is equal to mod square of mu12. So using this fact over here, we found that W21 is equal to W12. That is, the probabilities of absorption and stimulated emission are equal for the case of a single two-level atom. So you see that we wanted to calculate the stimulated emission transition rate W21. And we have found that the stimulated emission transition rate W21 is equal to that of the absorption rate. So this is the end of slide number 37.